case study, we look at controlling variability. And to do this, we use the PICSA case study. This is a case study that's given in more detail back in topic 1, alongside a paper related to it and the data for you to dig in and explore for yourself. But as a general overview to this study aims to assess the performance of PICSA training by conducting both quantitative and qualitative surveys among some of the farmers who took part in the training. Quantitative, just as a reminder, are kind of those questions which kind of have those checkbox answers or more numerical answers, whereas qualitative is more questions which are more open-ended. For example, a qualitative question might be, how did you find the training? I'm sure that it was a lot more specific than that, but you know, how did you feel about the training after completing it? And if that's a qualitative version of that question, it'll kind of be a little box where the user can say how they felt, either by typing in or I believe these surveys were done face-to-face with enumerators going around, so face-to-face then. And so you kind of get that more written feedback, as it were. A quantitative version of that question might be with kind of checkboxes saying, or radio, but you know, but just options saying like good, fine, bad, very bad, you know, very good. Anyway, in PICSA, there's a target population which consisted of approximately 4,700 farmers spread across 124 communities in 6 districts in northern Ghana. So to kind of explain that in other terms, there's 4 of the people that took part in the training. That's our population here. Our population are the people that did the training. And of that, there's 4,700 individuals. And they're spread out in northern Ghana across 124 different communities in 6 different districts. There's therefore a kind of large amount of variability across this population of 4,700 farmers. We might have different conditions, such as we might have different cultures between our different communities or our different districts. We might have different weather patterns between the different districts, you know, or more north being a different weather pattern to more south. All the trainers of the course may have impacted the farmers differently, or the enumerators, the people that asked them the questions, might have, while they would have stuck to a script, might have mentioned it differently, kind of put certain inflections on words, or might have accidentally swayed in one way or another as well. So there can also be a whole other range of reasons of variability out there, of course. These are just a couple of examples of why there might be some variability in our answers between all of our farmers. And so our case study wants to make sure, or in this case study, they want to know how did people find the training, but they want that representation fairly across all 4,700 farmers. But they can't ask all 4,700 farmers because they don't have the resources. It's not time efficient. Even if they were to ask them all, there's then they might have issues with processing that data. So it's not practical to have that level of communicate. It's not practical to ask them all. It's not possible to. It might not be possible to anyway in this case. So they want to take a sample from this 4,700 farmers. They could take just a random sample scattered all across the region, but they also need to think of the practicalities of taking a sample. They don't want the enumerators, the individuals who are giving the surveys, they don't want them to have to travel around too much. You don't want to have, you know, or if we're talking, you know, all of northern Ghana, we don't want to have an enumerator have to go from here, travel 200 miles this way to do the next survey, travel another kind of 100 miles east to do the third survey, and so forth. So we want some restrictions in there. So we want randomness to ensure that representation among our 4,700 farmers that took part in the training, but we still want some restrictions to avoid, on a more practical level, we want those restrictions for our enumerators. So as a result, and I'm sure that they explain this in the paper as to why this number was chosen, but a total of 416 households were randomly selected across 20 communities. And if we remember, we had 124 communities. So about 1 in 10, roughly 1 in 10 was surveyed. And in our image here, I do note that I clearly haven't highlighted 1 in 10, but this is just a little image for us just to get an idea of, okay, well, you know, we surveyed them and not them. But yeah, roughly 1 in 10 people would have been surveyed, and those 20, and this is, you know, 416 households between 20 communities instead of 124, and those 20 communities would have also been selected in such a way that there's no point selecting those 20 communities that are all together in one region, because we want to account for that variability due to, as we said, due to these different cultures, weather patterns, and so forth. So we want our 20 communities to be spread out a little bit, but within those communities, we're sampling approximately 80 people within a community. This method, anyway, is known as stratified sampling. And it shares a good level of spread across our different districts. So maybe just a little bit on stratified sampling. So this is like that you've got a large group and you divide it into smaller subgroups based on certain characteristics. And then you randomly select samples from within each subgroup. So this will ensure that every subgroup is fairly represented in the final sample, giving a clearer and more accurate picture of the whole group. So here we've got some little cartoon people, and we can see that we've got 8 blue, 4 green, and 4 orange. I suppose that's an orange, maybe a brown. And so if we were to say, you know, how back here we had that there are oops, sorry, it's not letting me go back. But anyway, as we said that there's 124 communities in 6 districts. If we were to kind of hypothetically say that here we had 3 districts, we had the blue district, we had the green district, and we had the orange district, and our blue district was bigger, then we would want to sample more from the blue district. This is some kind of stratified sampling. So we sampled kind of 50% of people in each of our districts, and that results in 4 blue, 2 green, and 2 orange. One objective of the PICSA survey was to evaluate whether individuals had made any changes following the program. There's always a risk with a survey that respondents may provide inaccurate or exaggerated accounts just to please the surveyor, rather than reporting the kind of truth about their actual behavior. So how the PICSA survey chose to mitigate this risk was to use a participatory approach, which is conducting qualitative interviews on a small subset of the sample. So we've got our 4,700 farmers. We've sampled 416 of them on our kind of written on our first survey, and then we have interviews to a further 30 of those 416. The households were carefully chosen from those 416 respondents. The selection criteria aims to provide an accurate representation of various factors identified in a quantitative survey. So this is now a quote from the paper, but gender, changes in crops, livestock, and livelihoods, and those that had made no changes based on the PICSA approach. So they really wanted to given the responses that they got, given those 416 individuals' responses, they wanted to take those responses and use that to help decide which 20 people to interview, which 30 people, sorry, to interview, and have a real representative set of interviews. You don't want to just interview those people that came across and said that they made no changes in crops. You don't want to just interview those people that said that that we had made loads of changes based on the approach. You want to know individual people's accounts. So they took the time and they decided which sorts of people do they want to interview, and they chose 30 people based on those 416 respondents. This is now a stricter stratified sampling. And this method ensures that a diverse range of perspectives within the qualitative interviews was given, and it is an example of how sampling can be used to control and manage variability. So in conclusion, the layout of the study design is a fundamental tool to help control and manage variability in a study. Stratified sampling has been used in the PICSA case study to ensure a fair and representative sample. And this is just one example where they tried to mitigate against further biases being introduced into the study. There are many other things that they would have done in their study design to help mitigate these kind of biases. There would have been replication and things like this, which goes into a lot more detail in the paper. But this is just one example relating to surveys of how they did this. Thank you.